I'm just looking at it. I want to look at it.
Chapter 4-4 continued here. What you need to know are reference angles. Now, a reference angle is basically an angle that is less than 90 degrees. Okay? A reference angle is given an angle theta in standard position. It's very, very important. Its reference angle is the acute angle theta prime. Acute meaning what? Smaller than 90, so an angle between 0 and 90. Formed by its terminal side of the angle theta and the horizontal axis. That is essential. There's two things that are essential here. That is an acute angle, and it's formed by the angle theta and the horizontal axis. Okay? Those two pieces of information are extremely important. Now, I'm going to go through here and we're going to talk about all the different lovely little quadrants.
That was what?
If you are in quad 1, here's my angle, theta. How do I find theta prime? My reference angle. Well, reference angle is supposed to be an acute angle. Well, if I'm in quad 1, am I an acute angle? Yes. So do I have to worry about anything in quadrant 1? No. In quadrant 1, theta and theta prime are exactly the same thing. Theta and theta prime, which are my reference angle, they are exactly the same thing. Does that make sense? However, when you are in quadrant 2, there's my theta. Now, how do I form an acute angle for my reference angle? What are the two important things I have to use? I highlighted them. It's really hard to miss it.
Horizontal axis.
The horizontal axis and theta. Those are the two angles, the two things that we have to use. So you got to keep in mind, I need theta prime. Well, theta prime is that angle right there. How do I find that angle? How do I find that angle? Theta prime is going to be equal to what? Theta. Well, what happens if my angle is not in degree mode? How about pi minus theta, right? Whenever your theta is given, if it's degrees, you're going to use 180. If it's going to be radians, you're going to use pi. We all understand that, yes or no? Why am I using pi? That is going to be your horizontal axis. You're either going to be using pi or 180 or 0 or 360 or 2 pi. Okay? Now, what if I'm in quad 3? There's my lovely theta. Now, how do I find theta prime? Remember, how do I form theta prime? Still got to use your horizontal axis, so how do I find theta prime? Can you ever use 270? No, because that's using the vertical axis. I need my horizontal axis. What's my horizontal axis? Where's theta prime at? It has to be an angle less than 90 degrees. So that's going to be right here. How do I get that? How about theta minus 180? How about theta minus 180? I mean, it's a very easy concept, guys. You guys are way overthinking this concept. You're going to take your angle and subtract 180 from it. That's going to give you your little piece of that theta prime. Okay, well now I'm going to be in quadrant 4. In quadrant 4, there's going to be my theta. Now how do I find theta prime? It's formed by using the horizontal axis. The horizontal axis is there, so therefore this is going to be my theta prime. And how do I find theta prime? Can't use 270 because that's the vertical axis. Horizontal axis.
Is this where I use 360?
Uh-huh.
360 minus theta?
Uh-huh. 360 minus theta is correct. Now, what if my theta is negative? You're going to do the opposite. You're going to add, right? We all understand that. Okay, we've been subtracting, but if your theta is a negative angle, you're going to do the opposite of what theta is. So now you're going to add the 260 or the 180 or the 360. We understand that. Okay, tonight's homework is chapter 4-4, 36 through 98 even. 36 through 98 even.
You got it.
We're going to start right into tonight's homework.
You got it.
I'm going to start right into tonight's homework, so get out a sheet of paper so we can do homework together. Yeah. Let me go through this first, and then at the end I'll go through that. I want to make sure we understand every set of instructions before I go on. Okay, here we go. Number 38. 38 in tonight's homework. It simply asks you to find the reference angle theta for the specific angle. Actually, find the reference angle theta prime for the specified angle theta. And sketch theta and theta prime in the standard position. Well, isn't that what I did in quad 1, 2, 3, and 4? I gave you generic angle theta, and then I sketched the angle theta prime. Okay, so let's do number 38. Where's 225 at? What quadrant is 225 at? Quadrant 3. There it is. There's theta. How do I find theta prime?
Minus 1. Theta.
So since I'm in quad 3, theta prime is going to be equal to theta minus 180. So that's going to be 225 minus 180. And what's that going to give you? 45 degrees. That's how you find theta prime. Do we understand that? If you don't understand it, ask me a question. I don't know what you don't get.
I'm being dead serious.
Where's 225 degrees at? It's right here in quadrant 3. According to quadrant 3, what do we do? So what did I do? Okay. 44, I have theta is equal to negative 2 pi over 3. So where's negative 2 pi over 3 at? Well, that has a denominator of 3, so we're counting around the unit circle with denominators of 3, correct? More importantly, not by 3s, but probably by 6s, right? Because that's a 60-degree angle. 2 pi over 3 is going to be right here. Okay, and it's opening in quadrant 3 again. However, it's a negative angle. So we all understand that. And I talked about that just a little bit ago. When we have a negative angle, what are we actually doing? We're going to do the opposite. So this is going to be theta prime is going to be equal to theta plus the 180. In this case, it's going to be theta plus pi. We understand that. Why are we doing theta plus pi here?
Because in radians, not in degrees.
It's because it's in radians, not degrees. But why am I adding this time?
Just a negative.
Because your theta is a negative angle. It's negative 2 pi over 3 plus pi to give me what? Negative 2 pi over 3 plus 3 pi over 3 to give me pi over 3. Is that an angle smaller than 90 degrees?
Yes.
Yes. Is that my reference angle then? Yes. Do we understand that, Jet?
I just wanted to know, do we have to draw the graph out when we're
Yes.
doing the homework? We do?
Yes. It says to draw the graph. This part right here is going to be theta prime. You need to put everything that I have on here. You need to have on paper. That's what it's asking for. Now, the next set of instructions is 45 to 52. I have no idea why they have them. I guess I do know why. The only reason they have them separated is because you do not have to sketch the angle from 46 to 52. But it's the same exact concept. Okay? Same exact concept. 53 through 66. Says evaluate the sine, cosine, and tangent of the angle without using a calculator. So where is this going to go right back to? The unit circle. So if we're looking at number 60 where it says 3 pi over 4, well, get the hands of the clock in your head. What do I mean whenever I say the hands of the clock? Right? talking about the point, 1/2, square root of 3 over 2. Square root of 2 over 2, square root of 2 over 2. Square root of 3 over 2, comma 1/2. Remember I said 1, 2, 3? Answer your clock. What angle is 3 pi over 4 relate to? The 45-degree angle. Okay? So what I'm talking about using these points right here. Do we understand that? Where is 3 pi over 4 located at on the unit circle? What quadrant? It's located in quad 2. In quad 2, that's going to be the negative positive quadrant. Do we understand that? If it's the negative positive quadrant, what do we know about my tangent? Tangent's going to be negative. Remember that whole face concept I always draw in there? Okay? So that means I'm going to go right over here to sine 3 pi over 4, cosine 3 pi over 4, tangent 3 pi over 4. Well, we already know they're all the square root of 2 over 2. These two are. And which one's going to be negative? Sine or cosine? Cosine's negative. Sine stays positive because we're in quadrant 2, right? And what's the tangent of 3 pi over 4? Well, what's the square root of 2 divided by the square root of 2? Square root of 2 over 2 divided by square root of 2 over 2. What's 5 divided by 5?
1.
What's the square root of 2 divided by the square root of 2? What's the square root of 2 divided by 2 divided by the square root of 2 divided by 2? 1. In this case, it's not going to be 1, but negative 1 because in quadrant 2, the tangent is negative. Do we all understand what we need to be able to do? Okay? I do not want decimals. You hand me decimals, you get an F on your homework. Am I clear?
Let's not find out easier now.
Denominator 4 always goes to the square root of 2 over 2. Denominator 3 is going to go to the 1/2 square root of 3 over 2. Denominator 6 is going to go to the square root of 3 over 2, comma 1/2. Every time. Okay? Did we get that? Go to the next set of instructions. Now, I do want to talk about 64 and 66. Look at those a minute. 64 and 66. If I talk about 64 a minute, 64 is 10 pi over 3. Is that on my unit circle? No. So since that's not on my unit circle, wouldn't it be nice to find the coterminal angle that it relates to? So what am I going to do here? I'm going to subtract 2 pi, which means I have 10 pi over 3 minus 6 pi over 3 to give me the 4 pi over 3. Now is that on my unit circle?
Yep.
Yes. So what I'm actually doing is the sine at 10 pi over 3, which is the same thing as the sine at 4 pi over 3. Do we all understand that, yes or no? What quadrant is 4 pi over 3 in? This is in quadrant 3. Well, when you are in quad 3, you have the minus minus and the tangent would be positive, correct? Which means this relates to a denominator of 3. So Trish, can you tell me what point we're talking about here that's relating to the denominator of 3? Yes. Looking at the end of the clock, that's a 60-degree angle, so that's going to be the square root of 1/2 square root of 3 over 2. So what's going to be the sign? Positive or negative? Negative. Cosine of 10 pi over 3 is the same thing as the cosine at 4 pi over 3, which is going to be what here? Negative 1/2. The tangent of 10 pi over 3 is going to be the tangent of 4 pi over 3, which is going to be what? Well, if you have not done that in your head, not written that down on your paper, if you have to do this, literally, negative square root of 3 over 2 divided by negative 1/2 is going to be the square root of 3 over 2 times 2 over 1 to give you the square root of 3. That is simple fractions. Divided by the reciprocal. Divided by a fraction, you can multiply by the reciprocal, right?
I used to think I was so hard finding the thing. I actually took my 10 seconds in my car. I realized it.
So easy. Okay? Tangent is sine over cosine. Do you understand why I purposely write sine first? Do you see I purposely do that every time? So I can see the fraction in my head. There's the fraction, right? You see it? And as soon as you see your denominators are the same, they automatically cancel out. No, what you need to tell me is you need to say what quadrant it's in. Why do I need you to always think quadrant? Positive, which one's negative, what the output of the tangent is. Okay, I need your brain to always go back to that quadrant concept. All right? Does everybody understand why memorizing the unit circle is so important now?
Yeah.
Wouldn't this make it so much harder on you if you did not? Okay, going on to the next batch, 72. It says find the indicated trigonometric value in the specified quadrant. They give you the secant of theta is -9/4. They tell you that you're landing in quadrant 3, and now what they want out of that quadrant 3 is going to be the tangent value. Okay? So again, they give you this function value. They're telling you the quadrant that they're in, and then they want you to calculate the tangent value. Do we understand that, yes or no? There are several different ways to do this. Okay, there are several different ways to do this. The first way is you can use the triangle. Triangle, you can always go back to a triangle. Because if you know secant, what is secant the opposite of? Cosine. Cosine is adjacent over hypotenuse, which means secant is going to be hypotenuse over adjacent. Okay, the adjacent is going to be a negative, and so is going to be the opposite. Now, you can make this into a lovely little triangle. I'm not going to. I'm going to force you guys to use trig, because you guys hate to use trig, and I need you guys to learn the identities. Now, if you guys go back to that identity page that we talked about previously on page 270, you're on page 270, or I think I made you guys mark another page. Page 340, same concept. You have Pythagorean theorem definitions there. Okay? What did they give us? They gave us secant. So what Pythagorean theorem identity would you want to use if they give you secant? 1 plus tangent squared of theta is equal to secant squared of theta. They give you secant. They want you to find tangent, right? Well, before I even move on, I want you guys to understand I'm in quadrant 3, so what do I know about quadrant 3? Sine and cosine are negative, and my tangent's going to be positive. Your brain needs to know that immediately, which means now I can go right back and apply that lovely little theorem. 1 plus the tangent squared of theta is equal to the secant squared of theta. And I'm going to solve this thing for tangent right away. So I'm going to have tangent squared of theta is equal to the secant squared of theta minus 1. Do you see that? Yes or no? Okay, what do I know secant to be? What's secant? Plug it in. What's -9/4 times -9/4? (81/16) minus, what does that 1 have to turn into? 16/16. And what is 81 minus 16? 65/16. Now I need to find tangent. So what do? Take the square root of it. Now whenever I take the square root of this thing, technically I should have a plus or minus thing going on here. However, which do I want? The positive or the negative? Why do I want the positive? Because I'm in quad 3. And because I am in quad 3, that implies that the tangent of theta has to equal positive square root of 65 over, and no one caught me, I put 316 there, it should be 4. Over 4. We all see that. Square root of 16 is 4, guys. Sorry about that. I got rid of the square root, but I forgot to change 16 to a 4. Do we get that, yes or no? Do we all see that? Do you have to use the trig identities always?
No.
Could you use the triangles if you so desire?
Yeah.
Do you already know how to do triangles? Am I going to show you how to do that? No, I'm going to use the trig identities every time. Because I'm in quadrant 3. And in quadrant 3, sine is negative, cosine is negative, tangent is sine divided by cosine, negative divided by negative is a positive. That makes sense? Okay, now are we good on that? The next section of directions says 75 through 90, use a calculator to evaluate the trigonometric function. Round your answer to 4 decimal places. Be sure the calculator is set in the correct angle mode.
I can do that for
Now, if you are using My Inspire calculators, do you have to change your mode? No. If you stay in radian, that's completely fine, but whenever you do a degree, what do you have to add?
degrees.
The degree symbol. Do we all understand that? If you are in an 83 or an 84 calculator, then you have to change the mode. Do you all understand me? It's not that hard to change them. Okay, I'm not going to go over those ones. You should be able to do that. 91 through 96. The directions say, find 2 solutions of the equation. Give your answers in degrees, 0 to 360, and radians, 0 to 2 pi. So, you kind of don't need just 2 answers, you need 4 answers. The reason why you need 4 answers is because if it's 45 degrees, they want you to give the pi over 4 equivalent. If it's going to be 30 degrees, they want you to give the pi over 6 equivalent to that. Does that make sense? Okay? Now, what they want to know is what angle has a cosine equaling the square root of 2 over 2. Well, first of all, I need your brains to go back to this right here. Positive, 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 negative, positive, negative, 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 positive, positive, negative, negative. Your brain needs to keep that chart in your head. What is that chart again? Sine, cosine, and tangent values in each quadrant. Agree? Okay. What quadrants have a positive cosine? 1 and 4. So I'm going to be in quadrant 1 and 4 if I have the square root of 2 over 2 positive. Do we understand that? What angles have a cosine positive square root of 2 over 2? 45, which is what? Pi over 4. That's quadrant 1. Now, what angle in quadrant 4 also has a positive square root of 2 over 2 cosine?
It'll be 7 4.
Well, it's going to be 7 pi over 4. The reason why we know it's 7 pi over 4 is because what did you immediately do? You changed 2 pi to have the same denominator as a 4, right? It made that 8 pi over 4, and you simply subtracted pi over 4 units from it, right? To give you the 7 pi over 4. Well, what's 360 minus 45? 15. There's your 4 answers that you need. Does that make sense? It's all about knowing your unit circle. Okay? Go to the next one. What angles, quadrants I should say, have a negative cosine? That puts us in quadrant 3 and 4, right? So what angle in quad 2, sorry, did I say 3 and 4? I meant quad 2. What angle in quad 2 has a negative cosine square root of 2 over 2? It's a 45 degree angle, but what angle is in that in quadrant 2? 135. And if you're thinking about this, make this pi to be 4 pi over 4. Subtract 1 away, and that gives you 3 pi over 4. Again, if this is 4 over 4, that's going to make quadrant 3 be 5 pi over 4. So give me 180 plus 45 to give you 225. Do we see that, yes or no? It's a matter of knowing your unit circle. Yes? 96. Last one I'm going to do. Same exact concept, except for this time, what do I know? I'm going to go right back over here, draw my lovely little okay? Cotangent's negative in what quadrants? 2 and 4. Cotangent's negative in quadrants 2 and 4, right? How do I get lovely little square root of 3 for a cotangent? Well, I'm pretty certain that square root of 3 is not anywhere near a 45 degree angle, right? Because you're not going to get a square root of 3 answer. So that leaves me either 30 or 60 degrees, right? It's either 30 or 60 degrees. So if I'm going to do, which one do you want to do first? You want to do 30 or 60? 30. So if I'm going to do the sine of 30 degrees, the sine of 30 degrees is going to be 1/2. The cosine of 30 degrees is going to be square root of 3 over 2. The cotangent of 30 is going to be my cosine divided by my sine, which is going to be the square root of 3 over 2 times 2 over 1 to give you the square root of 3. Notice that is the cotangent, cosine over sine. Does it work?
That doesn't work.
So, I know the cotangent of 30 degrees is the square root of 3. However, it's positive, right? I'm in quad 2 and in quad 4. So I need my 30-degree angles that are representative, that are being represented in those two quadrants. So what are my two angles in those quadrants? I need my 30 degrees, so that makes this 6 pi over 6. What's that going to be over here? Why did I make that 6 pi over 6? Because 30 degrees is pi over 6, right? So what's my angle in quad 2? 5 pi over 6. So if it's 30 degrees, 180 minus 30 is 150. Now I need this one. This one's going to turn into 12 pi over 6. So what's that going to be? 11 pi over 6. So that's going to be 360 minus 30, which is 330. Do we see that? Yes or no? It's simply knowing your unit circle. Secant is going to be the square root of 2. Well, if I know secant, what else do I know? Cosine. So, confusing. What angle is going to have a cosine of 1 over the square root of 2? Why did I say that? Well, because they're the reciprocals of each other, right? Can I rationalize that? So what's that going to be rationalized? So what angle has a cosine of the square root of 2 over 2? We know that, don't we? We know that's 45 degrees. So what angles have cosine being positive? Quadrants 1 and 4. Okay? So now, what angle am I talking about in quad 1? 45, which is pi over 4. And then what angle am I talking about in quad 4? This is not going to be a 12 pi over 6. Now this is going to be an 8 pi over 4. And that's going to give me, what is it? 7 pi over 4, which is going to give me 360 minus 45, which is 350. Now, this is not difficult. It's using logic, okay? You gotta think. You gotta think. You just can't write down a random answer and say, hey, that's right. You gotta think about it, okay? Now, we have questions over last night's homework. What questions do we have?
18, 22, 24.
Steph, what were yours? What number? 16, so we can do 18. That'll make you and Colton happy. 18. The cosine of theta is equal to negative 4 over 5. And I am in quadrant 3. The directions say what? Find the values of the 6 trig functions. So if I need to find the 6 trig functions, I already have one value. Now I need to find the other one. I'm in quadrant 3, so what does that imply? Right? Okay, I need to find, what is cosine defined to be as? Cosine is defined to be x over r. So in this case, x is going to be my lovely negative 4, r is going to be my 5, and I need to find y. Do we all see that, yes or no? You see that? So if I use this formula, x squared plus y squared is equal to r squared, x is going to be negative 4 squared, y I don't know, r is going to be 5 squared, so y squared is going to be equal to 25 plus or minus 16, sorry. Why is it minus 16? Because I took it over the other side, right? What's 25 minus 16? 9, so now I need to take the square root, and y is going to be equal to plus or minus 3. Which one do I take? Why do I take the minus? So y is going to be -3 because I am in quad 3. Can we see that? So now all I have to do is find my sine. Well, sine of theta is going to be y over r, so that's going to be -3 over 5. Tangent is going to be y over x, which is going to be y is -3 over -4 to give you 3/4. So that means I know cotangent, which is going to be 4/3, which means I know cosecant, which is going to be -5 over 3, which means I know secant,
-5 over
-5 over 4. You automatically know the other one's yes. Whenever they give you one trig function, you automatically know.
Well, for one, they just showed me how long the data like it didn't work that way. Like you said, like if they gave me a tangent or something, and I said, "What is that tangent to this?" You said, "No."
Remember, you are not acknowledging the hypotenuse. I told you you can't ignore it. You are forgetting the r value here. That's because we hadn't gotten the r value yet. You're dealing in terms of, you said if I know the tangent, then don't I automatically know what sine and cosine are because that's going to be x over or y over an x. And I said no because you got to acknowledge the whole hypotenuse. Hypotenuse does cancel out. Yes. But you're still, if you're given tangent, you automatically know cotangent. That's what I'm saying. If you're given one, you automatically know two. If you're given cosine, you automatically know secant. If you're given sine, you automatically know cosecant.
Right.
No, you still know. If you're given tangent, you still know cotangent.
Like it gave you like sine,
Then you'd automatically know cosecant.
but then I put down that cosecant and it wasn't right. Like sine was like 1/2, and then it added the cosecant.
There's no speaking.
Then when you get up to 4,
Any other questions? We still have 2 more minutes here. Any other questions? What do you need to do for last night's homework? We're all good? Does it help whenever I start your homework with you?
Yes.
Nice to